This lesson is on measures of center, box and whisker plots, and histograms. Before we get into the math, we're going to look at some vocabulary. We're going to be using these words and finding these things for different sets of data. The mean is the average of a data set. When you find that, the mean is equal to the sum divided by the number of values. The median is the middle value. And this is when the numbers in the data set are in order from least to greatest. And don't forget that with median, whenever you have an even number of values, you take the two middle values, add them together, and divide by 2. So you're finding the average of those two middle values. The mode is the value that occurs most frequently. The lower extreme, sometimes also called the minimum, is the lowest value. Its opposite is the upper extreme, or the maximum, and that's the highest value. We've got the lower quartile, which is the median of the lower half of the data. This is sometimes called the first quartile or quartile 1. The upper quartile is the median of the upper half of the data set. And this is sometimes called Q3, with the median being Q2. The range is just the maximum minus the minimum. And to find interquartile range, it's Q3 minus Q1, or the upper quartile minus the lower quartile. Now let's look at some examples. Given this data set, find each value. So for the mean, the first thing I have to do is find the sum of all the values. In this case, that's 130. I'm going to divide by the number of values, which is 10, and find that the mean or the average is 13. For the other values that we're going to find for this data set, it's important that the data set be in order from least to greatest. So you can see here on the left that I've put all 10 of those digits in order from least to greatest. To find the median, I want the middle. Now this is an even data set. So that means that there's an even number of values. So to find the median, or Q2, I'm going to have to find the average of 10 and 14, which is 10 plus 14 divided by 2, which is 24, divided by 2, which is 12. So the median in this case is 12. The mode is the value that occurs most frequently. In this case would be 10. It occurs 3 times. The lower extreme, or the minimum, is 4. The upper extreme, or the maximum, is 25. Now, that lower quartile range, I'm going to take this lower half of the data set, and I'm going to find the middle value. On this side, there are 5 values. The middle one is 10, so that's my Q1, or my lower quartile, or my first quartile. And in the upper half of the data, I'm going to find that middle value, which is 16, which is my upper quartile, third quartile, or Q3. Now to find the range, I take that maximum value and subtract the minimum value. So the range is 21. And for the interquartile range, I'm going to take that Q3 and subtract Q1. And that gives me 6. So all of those values, relatively easy to find. Remember to put the data set in order from least to greatest. Now we're going to look at box and whisker plots. And the important thing here is to be able to interpret the graph. So on our box and whisker plot, we've got the minimum value and the maximum value at either end. In our box, we've got Q1 and Q3 on the outsides and the median value in the middle. It's important to remember that each section of the graph represents 25% of the data. So even if the sizes look different, each section of the graph is 25% of the data. Now that we know how to read those graphs, we can go ahead and find some values from them. So what is the median of each set? Well, the median, I'm looking for that middle line inside the box. So here, for both sets, it happens to be 70. The next question asks about the range. Remember, the range is the maximum minus the minimum. So the range for set A would be that maximum of 100 minus the minimum of 50, which is 50. The range for set B would be that maximum of 100 minus the minimum of 40, which is 60. So set A has the lesser range. The next question asks about the interquartile range. Now to find that, I'm going to take Q3 and subtract Q1. So for set A, that's 80 minus 65. So that's 15. If I look at set B, that's 85 minus 60, which is 25. So set B has the greater interquartile range. Now, the upper quartile of each set is Q3 of each set. So for A, it would be 80, and for B, 85. The lower extreme is those minimum values. So for set A, the minimum is 50, and for set B, the minimum is 40. The next question asks, what percent of the data in plot B is between 60 and 85? So the percent of data between 60 and 85. Well, that's two sections of the graph, and each section is 25%. So that's 50% of the data. If I look at plot A, what percent is greater than 80? That's from here to here, from Q3 to that maximum, and that's only one section of the graph, so that's only 25%. So even though that looks like a large portion, It's just that section, and each section is 25%. All right, what percent of the data in plot B is less than 85? So for less than 85, I'm going from that Q3 to that minimum. That's 3 sections of the graph. So that's 75% of the data. Next, we're going to look at stem and leaf plots. Stem and leaf plots are a way of just displaying data values. Doesn't tell us necessarily anything about the value. It's important to remember that the value on the left, or the stem, counts the tens. The value to the right, or the leaf, counts the ones. So if you have a 7 on the left and a 2 on the right, that is equal to 72. So what were the highest and lowest scores? Well, the highest is going to be at the bottom with that stem of 9 and that leaf of 6. So the highest score was 96. And the lowest score would have been 52. Now I'm looking at which test score occurred most often, or the mode. I've only got a couple of values that repeat, 74 and 83. But that 74 repeats 3 times, while 83 only repeats twice. So 74 is going to be our mode. In which 10-point interval did most students score? Well, the stem that has the most amount of leaves is 7. So that means that most students scored in the 70s. The next question asks how many students scored 70 or better. So 70 or better would be these values here. So there were 6 that scored in the 70s, 3 in the 80s, which makes 9, and then 4 in the 90s, which makes a total of 13 students that scored 70 or higher. When looking at how many students scored less than 70, that would be with the stem of 6 or 5, and there were 7 students who scored less than 70. The next stem and leaf plot looks a little odd. It's got the stems in the middle, and then it's got the data set split into morning and afternoon with the leaves on the left and the right. The stem from the middle is still the number that comes first. It's still counting the tens. So looking at the highest morning humidity, that's only the values on the left, and the highest one has a stem of 8 and a leaf of 9, which is 89. The lowest afternoon humidity would be 51. The next question is a little bit of an interpretation of the graph. Does humidity tend to be higher in the morning or the afternoon? Well, looking at that graph, I can see that the morning has higher stems than the afternoon. So then the morning tends to be more humid. Now we're going to take a look at histograms. Histograms are just a way of grouping data by intervals. You may have heard these called bar graphs in the past. It's more correct to call them histograms. So let's look at the first one, the one on the left, number 11. So the data in this histogram represents scores on an algebra test. So we've got scores on that x-axis, number of students, or the frequency, on the y-axis. So how many students in total took the test? So if you look at the frequency of each bar on the histogram, that tells you the number of students that scored within each interval. If you add them all together, you get that 33 students took the test. How many of those students scored at least a 71? Well, that would be everybody in these 3 bars. So I would add those frequencies and get 26. The next question asks if we can determine the highest grade from the histogram. So this histogram doesn't show us individual scores, it just shows us intervals. So in that highest interval of 91 to 100, I'm not sure if any of those students actually scored a 100. I just knew that they were somewhere between 91 and 100. So there's no way to determine the highest grade from the histogram. In the next histogram, we're looking at the top 25 movies in a recent year and their revenue. So we've got revenue in millions of dollars across the bottom. And on that y-axis, we've got the frequency or the number of movies. How many movies grossed at least 141 million? So we're looking for 141 million and greater. So that's going to be all of these bars over here. So in that first interval, we've got 5, 1, 2, 2, and 2. So when I add all of those together, I get that there were 12 movies that grossed at least $141 million. How many movies grossed between 61 million and $180 million? So that's 61 million up to 180. So that's those three first bars. So that would be 19 movies in that range. And that last question asks, can you determine how many movies grossed between 121 million and $140 million from the histogram? The answer is no, because 121 to 140 is not one of my intervals, so I cannot determine how many of those values would be in that range. So now we've looked at different ways that data can be represented and some values that we can gather from those graphs. Next, we'll take a look at how to analyze some of that data and interpret what some of it means.